Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about the Drake equation. The equation that attempts to solve or give some kind of estimate or answer to the Fermi paradox, which is, if the universe is so vast and so old, hundreds of billions of galaxies with hundreds of billions of stars, for billions of years it has been here. It's truly mind-numbingly vast when we really think about it. All of this taken into consideration, billions and billions of opportunities for life to arise. Where is everyone? Like, truly, this is like a real question if you start to think about. So then we have something called the Drake equation, and essentially, so this is it. So n marks the number of possible civilizations given by this whole equation. First part of this equation, you see we multiply everything with everything in sequence. We multiply stuff. So Rx is the first one, and this is the rate of star formation per galaxy. So an average number we can take is about one star formed per galaxy per year, which might not seem like much, but on the time scales of the universe, billions of years and millions of years, one per year is quite a good healthy number. So let's say one star per year is formed. So next we have Rx times Fp, and Fp is the number of stars that actually have planets around them. So the fraction, so the percentage of stars that actually have planets around them. And quite recently we discovered that actually most of the stars in our universe have planets. So we thought that we are unique in our solar system, but exactly pretty much like with anything else, especially in astronomy and cosmology, the more we learn about the world around us, the more we learn that we are not that special, and this includes planets as well. So most stars actually have planets around them, and if they have one, then it's very likely that they have many. So not just a few, but quite many. So let's say that Rx times Fp, let's say that Fp is about half. So half of the stars have planets around them. So next we have Fp times Ne, and Ne would be the number of these planets that actually have habitable zones in them, so habitable conditions. Again, I said this many times, I think we as humans, we are restricted in our thinking, in the sense that we think that life is only possible to arise on planets where liquid water is available. However, looking at even our own solar system, the moons of Jupiter, Europa and Enceladus, they are way further away from the sun than the Earth is, so we wouldn't think there to be any life on it. But actually underneath those moons there are liquid water oceans, which are hundreds and hundreds of kilometers of liquid water oceans far away from the sun, and these oceans, liquid water oceans, have been there for billions of years. So we thinking that, we need this Goldilocks star, not too close that the water boils and evaporates away, not too far away that the water freezes, that we need this just right spot. I think this is a bit limited, not even starting to talk about all the possible forms of different kinds of chemistry, life that might not even require water. But for the sake of argument, water is really good. Water is a good solvent. A lot of stuff can happen, chemistry can happen in water, so fair enough. Let's say that we need water for this. And among these planets, we said if there already are planets around the star, there's more than one usually. There are quite a few. So let's say that Fp times Ne, let's say that Ne is like, I've written here 1 to 5, let's say it's like 3. So per a star system that has planets around, maybe 3 of those planets have liquid water on them. So then we have Ne times Fl, and Fl is the actual chance of these stars that have planets, that are in the habitable zone, that have water, how many of these actually produce life on them. And this is already really tricky territory, because we have only one example of life, and this is life on Earth, of course. So a conservative estimate to what this Fl, that life actually arises, would be, let's say, is about 1% or something like that. Next we have FL times Fi, and Fi is the probability of these planets where life actually arises, the probability of this life actually evolving into intelligent life. And again, this is a question, we have no statistics available for us, so let's again say that Fi is let's say it's 1%, and then we have Fi times Fc, and Fc is the amount of these intelligent civilizations, how many of them actually developed into technologically advanced civilizations. So you might as well have plenty of intelligent life thinking creatures, but maybe they have no technology. So what part of them do develop technology? And here this is probably quite likely. So average estimate is about 10 to 20%. So Fi intelligent life, Fc technological life. So I would say once you have intelligence, and if you have a long amount of time, then I would say it's pretty likely you develop technology. It starts simple, just like it did on planet Earth, with really basic tools made of rocks and stones and sticks and whatever. And now we're at the age where you can watch this video on YouTube, and we can do some truly mind-numbingly crazy things. And our growth of technology is exponential. So we're only getting better at our technology in such a short amount of time. We'll get to this. So Fc, and then the final thing is Fc times L, and L, this big L here, is the length of these technological civilizations. How long, if they develop, how long do they actually survive for? And again, this is something we have no idea for. An estimate may be 1,000 years to 10,000 years to 100,000 or a million years. We just have no idea. Depends a lot on how optimistic or pessimistic people are. A lot of people say that it's surprising that we still survive to this day, given that we developed nuclear weapons. So a lot of discussions are going on. Maybe civilizations, maybe the reason we don't see civilizations in our galaxy, or signs of them even further away, is that once a civilization reaches a sufficient stage of technology, they wipe themselves out with biotechnology, nanotechnology, some kind of nuclear weapons, artificial intelligence gone wrong, a million things you can think of that would shorten the lifespan. But if we truly are talking about intelligence, I think that will not happen, and I'm one of the few people that I have faith in humanity and what we can do. But truly, it's a short amount of time, 1,000 years, but essentially, so you put all these things together, so rate of star formation, or you might as well have amount of stars or whatever, number of those stars that have planets around them, number of those planets that are actually habitable by whatever criteria we want to put to that. In our case right now, we put liquid water there. So then there is the chance on those planets where actually life can arise. Does life arise, and how often does it arise? And then from there on, how often does it actually get to intelligence? And there on, how often does it actually end up with technological civilizations? And then final question, how long do they actually survive for? And put all of this together, and we get the amount of current technologically advanced civilizations in our Milky Way. I don't know if we should include us in technologically advanced, but I would say we're pretty good. So depending on the numbers that we put in here, we might get from a really conservative, pessimistic estimate 1,000 technologically advanced civilizations in our galaxy, 1,000. Or if we're a bit more free and generous with our estimations, we could have like 100,000 civilizations currently just as advanced as us, or way more advanced. Because if you think about cosmic timescales, we have been here technologically advanced, I would say a few hundred years, or okay, we could stretch it out to a few thousand years. What is that in the lifetime of the universe? 13.7 billion years. What is a few hundred years, few thousand years? Nothing. So I think that is important to take into consideration, the time scales. We have this vast galaxy that we live in, and civilizations, technologically advanced civilizations, can be just in different timelines, in different times. Important to take into account. I think that if civilization truly advances to high technology, they will spread out enough, and they will actually be intelligent that they will be able to sustain themselves, to keep themselves alive. Currently, as humanity, we are going still through this weird teenage era of, we're polluting our environment and all of these kind of issues that we have. But I would say this is just a side effect of us kind of growing up. These are growing pains. This is absolutely natural. We are not bad, we're not evil, we're not careless. This is just what happens to a civilization that grows and advances at the rate and pace that we are advancing at. So this is a normal side effect, that we're ruining our environment with plastics, that we're polluting the planet and the atmosphere, that we're killing off other species, that we're cutting down forests. All of this is a side effect, but I would say that this only happens at the transitional phase, at the very infancy of technologically advanced or almost technologically advanced civilization. So this is just a baby sort of phase, and I believe that advanced civilization grows out of that phase really quickly. So I think even within a few decades, even currently, we are seeing more and more technologies that help us sort of fix all of these major global issues that we are facing, that we right now think are so difficult, impossible to solve, are not at the end of the day so difficult to solve. If you think about it, the world is just arrangement of matter and particles, and intelligence is really, really powerful, and intelligence is something that we are only gaining more of, including artificial intelligence, which could possibly help us with most, if not all, of these issues. But an interesting thing to note is that when we look at the actual Drake equation, we go from things that we are quite certain of, we are certain of. So rate of star formation, absolutely know it. We can look at it by observation. How many planets are usually around stars, we know it. There's no problem with that. How many of those have liquid water on them, totally know it, no problem. We have statistics, estimates. But it's the other half of the actual Drake equation that gets tricky. The further we go in that direction, the less we can be certain of these answers, what values to give to these questions. But an interesting thing is that as we get smarter and more technologically advanced, we are getting better and more accurate answers going along the way. I think as the more time goes by and the more we learn, the more accurate our estimation becomes. But in any case, in a really pessimistic estimation, we get around 1,000 civilizations per our galaxy. Naturally, that should arise a lot of questions, as where are they and why don't we see anyone? But that is a topic for another video. So I hope this was something interesting for you. If you have any thoughts, please share them in the comments. And of course, thank you so much for watching, and take care.